Hello everyone, welcome to today's lecture. In this lecture, we are going to learn about input-output interface. So, input-output interface enables transfers of data between internal storage and external I/O devices. Yes, internal storage, that is lied in our CPU, and the external devices like our keyboard, mouse, printer, etc. So the data transfer between that internal storage or the CPU with the external I/O devices, that is done via the input-output interface. In order to interface peripheral with the CPU, special communication links are required. Due to this communication link, the difference between the CPU and peripheral such as data transfer speed, mode of operations are overcome. Now in this figure you can see that this is one CPU and this is a peripheral devices. So if peripheral device wants to send data to the CPU or the CPU wants to send data to the peripheral device, at that time they cannot directly do this. Why? Because there are some reasons for that. Because the first reason is the speed. The speed of the CPU is very high. CPU can send millions of data in 1 second. So the speed of the CPU is very high. While in the peripheral devices the speed is very less. Now assume your keyboard, you can type only 2 or 3 words in 1 second, yes, or you can print only a few documents in the 1 second. So the speed is very different. So the speed of CPU and the devices is very different. So to match that speed would require some interface between the CPU and peripheral devices. So that is why the input-output interface is used. So now in this figure you can see that the processor is the CPU, has a 3 bus, which is a data bus, address bus and the control bus. Okay, and these are the peripheral devices, which is a keyboard, printer, magnetic disk and etc. So all these devices are connected with the bus of the CPU via the interface. So this interface is connected with control bus, address bus and data bus. So now as I said that the speed of the processor is very high. So when if suppose there is no interface, at that time processor sends a lots of data to the devices. So device can't handle that situation. And if our peripheral device sends some data to the processor, so at that time processor has to wait too long, yes. So that is one situation. So that's why we are using the input-output interface in between processor and the peripheral device. So now what happened that the data that is comes from processor, that is first given to the interface. Now interface send this data to the peripheral device with a required speed. Same as when we are providing some input from keyboard. So that is given as a serial, yes, one by one will provide input to the computer. So that input is stored into the interface. Now interface is made up with registers. So that whole data is stored onto the interface, and now interface send whole data to the processor in a one time with the fast speed. So this is how the interface will work. So this is the first use for the interface. The second use of the interface is that here processor or the CPU is the electric device, and here keyboard, printer, magnetic disk are the electromechanical device, yes, or electromagnetic device. So the signal that both device used is a different. The signal used by the peripheral device is different. Also the signal used by the processor is different. So to match that the signal must needs to in the required format. So that's why the interface is used for that. So that is the second use for the interface. And the third use is the data format that peripheral device send is different, and the data format that processor send is different. So to convert the data format in the required format, that is supported by peripheral device and that is also supported by processor. So that conversion of the data in the required format, that is also done via the interface. So that is why the interface is very useful to transfer the data. Here the main task is to transfer the data. Yes, the data is transferred from CPU to peripheral device or the peripheral device to the CPU. So in the data transfer, the main component used is the input-output interface. So that is the use of the input-output interface. So the I/O bus consists of data lines, address lines and control lines. As I said, the I/O bus from processor is attached to all peripheral interface. To communicate with a particular device, the processor places a device address on the address line. So when the processor wants to communicate with any of this device, then at the time processor first sends the address on the address bus, and each interface decodes the address and control received from the I/O bus, interprets them for peripheral and provide a signal for the peripheral controller. It also synchronizes the data flow and supervises the transfer between peripheral and processor. Each peripheral has its own control. For example, the printer controller controls the paper motion and the printing timing. So after decoding the address, the particular data or the particular signal is provided to the particular peripheral devices. Because the work of each and every keyboard is different. It is not something like the will implement one logic that if you processor wants to communicate with a peripheral device, at that time execute this logic. Because the work of keyboard is different, the work of printer is different, the work of mouse is different. Yes, so for that the different signals is used to call that particular peripheral device, to activate that particular peripheral device. So these are the difference between the peripherals and CPUs. So as I said that the peripheral device is the electromechanical and the electromagnetic device, and the CPU is the electronic device. The data transfer rate is very slower than the CPU in the peripheral device, while in the CPU the data transfer rate is faster. And the third difference is the data in the form of codes in the peripheral device, while the data is in word format in the CPU. So the format is also different. So to match this difference, we'll use the input-output interface. So to resolve these differences, computer systems includes a special hardware component between the CPU and peripheral to supervise and synchronize all input and out transfers. These components are called the interface unit because the interface between the processor bus and the peripheral device. The control lines are referred as I/O commands. The commands are as following. The processor sends some commands to the peripheral and peripheral sends commands to the processor. So the control lines are referred as I/O commands. Here, as I said that these are the control lines: data, address and control. So this control lines has their own command, something like this. Control command, the first command is the control command. So a control command is issued to activate the peripheral and to inform it what to do. Yes, there are multiple peripheral devices available. So from that, which peripheral device we want to activate and what task we want to perform. So that is done by the control command. The second is a status command. So a status command is used to test the various status conditions in the interface and the peripheral. So to know the status about peripheral or the processor, we'll use the status command. Next is the output data command. So a data output command calls the interface to respond by transferring data from a bus into one of its registers. So when we want to transfer data from bus to the register, at that time we'll use output data command. And the next is the input data command. So this data command is the opposite of data output. In this case, the interface receives item or data from the peripheral and place it in its buffer register. So input data command is used when the peripheral device sends some data to the processor, and the output data command is used when the processor sends data to the peripheral device. So this is all about the input output interface. So that's it. Thank you so much.